understand how to find the instantaneous axis of rotation. We know when a body is rotating, let's say this is a rod which has been pinned over here and this is rotating with angular velocity omega over here. So if we wish to know what is the direction of velocity of this point A, so what we do is, that is, we join this, the velocity will be perpendicular to this at an angle of 90 degree. This will be moving in this direction, and this, taking this as radius, this will be moving in this circle. Similarly, this point, this will also have velocity perpendicular to this in this direction. Let's say V2, this is V1. So V2 will be having a velocity. So V2 is going to be equal to R omega, and this V1 is going to be equal to R omega. If we have this irregular shaped body, we have to find, and this is rotating about this, and we have to find the velocity of this point. So it means we join these two. So velocity will be perpendicular to this. Similarly, the velocity of this we have to find out. We join these two. That is, this is a radius, and this velocity will be perpendicular to this radius. Similarly, over here, we join this, and velocity will be perpendicular to this radius. So we can find the velocity. So over here, we understand that is, velocity is perpendicular to the radius in which it is moving. And axis of rotation is over here. We join these two, velocity is perpendicular to this radius. Now we take a reverse case. Over here we knew where is the axis, where is the point, we have connected these two, and we have drawn the radius, and we say the velocity will be perpendicular to radius. Now let's understand it otherwise. What does it mean? It means if this is a body, this is moving in this direction, suppose V1, and this point is moving in this direction, V2, and we have to find what is the axis of rotation. We know if this is moving, this particle is moving is in this direction, so axis of rotation should lie on a line perpendicular to this. Similarly, for this, if it is moving in this direction, the axis of rotation should lie on a line perpendicular to this. Where these two lines intersect, this is the instantaneous axis of rotation. This point is instantaneous axis of rotation, and about this whole body is rotating with one angular velocity omega, 1 theta, 1 alpha. Now here, one thing was simple, that is, these two lines, they were intersecting. Suppose these two lines, they don't intersect. We have been given these two particles which are on the same line. Now let's take the case where the velocity of the two particles which are given, they lie on the same line. That is, if this point is given, has a velocity v, and this point has also velocity v parallel to this only, and this just below over here. So this point A and B, their velocities they are given. This velocity is in this direction, this velocity is also parallel to this in this direction. So now how to find the axis of rotation? We know the axis of rotation should lie in a line perpendicular to this, and for this also it should lie in a perpendicular line to this. But now how to find the axis of rotation? Both of them, the radius, they are on the same line. So what we do is, when the velocities they are given, velocity of A and B is given, we draw this in proportion to their magnitude. That is, suppose this velocity is given as v and this velocity is 2v. So whatsoever the length is, that is, we draw this length as double of this length, that is in proportion to the magnitude. So this is v, this is double the length, 2v. So one line is this is fine. The second line to find the axis of rotation is, that is, join these tips where these intersect, these two lines intersect, that is axis of rotation. So now at this instance we can say this whole body is rotating about this point as instantaneous axis of rotation.